Hi everyone, we are continuing with vectors. And so we're given a particle moving along the curve, and this time we start with our derivatives. So we're given dx dt and dy dt. And they tell us that at time 2, we have a position of 7, 4. Okay, so keep in mind this is position. Okay, these are derivatives. Okay, then they want us to write the equation of the tangent line at 2. So here's the nice thing. We already have our point. Okay, so our point is 7, 4. Okay, so what I need to do now is figure out what my slope is. Well, in order to do that, I need to know what dy dx is. Okay, and I know that dy dx is dy over dt divided by dx over dt. Okay, so these are all the things that I know. So I'm just going to go ahead and plug in. So dy dt is cosine, dx dt is sine, right? And I'm evaluating at 2. So my dy dx at t equals 2 is going to be cosine of 4 divided by sine of 8. So all I did was I plugged in 2. 2 squared is 4. 2 cubed is 8. Right, so now I can write my equation. We go to point slope form. So y minus 4 equals cosine of 4 over sine of 8 times x minus 7. And that is my tangent line. Okay, then they ask us to find the speed of the particle at 2. Right, so remember, for speed, you're essentially finding the magnitude. You're going to take the square root of my derivatives added together and squared. Right, so at 2, the value of my derivative of x with respect to t is sine of 8. But I'm going to square this. And then at 2, I'm going to have cosine of 4. And I got to square that as well. All right, we plug this into our calculator. Make sure you're in radians, and you get 1.186. Okay. Then they ask us when our tangent line has a slope of 4. All right, so there's a couple things here. What I want is, again, obviously for my slope to be 4, meaning I want dy dx to be 4. Okay, so I need, dy dt over dx dt to equal 4. So I'm going to have to find my intersection point, essentially. So what I can do is go to my calculator, and I typed in my dy dx right here, so cosine of x squared over sine of x cubed. Okay, and I can find this intersection point, and that would give me my time. Alternatively, you can use the solver. So if I go to math all the way down to solver, and all I did was I plugged in y1 minus 4. So in this case, this does not have the updated OS. You have to set it equal to 0. So you want your y1 to equal 4, so all I did was subtract 4 to the other side so that it equals 0. You go down here, you hit alpha, enter. You want that green solve. And we end up getting 0.616. And that's the same answer that you would get from your graph. Right, so I end up getting that t equals 0.616. Okay, now again, that doesn't actually tell me what my acceleration vector is. Okay, so I'm going to have to find my acceleration of 0.616. Okay, well, in order to do that, I need to figure out what my acceleration vector is in general. Right, and so we start with our velocity vector, essentially. Okay, they give us dx dt and dy dt. Well, I need to figure out what the derivatives of those are. Right, so we're going to take the derivative of dx dt, which is going to be 3t squared cosine of t cubed. Okay, and then the derivative of dy dt is going to be negative 2t sine of t squared. Okay, now I can take this and in my calculator plug in 0.616, and you should get 1.107, negative 0.456. Okay, and last they ask us to find the position of our particle at time t equals 1. Okay, so we kind of started with velocity, and so now I need to go backwards to position. So that's going to involve taking the integral. Now what I can do is, I'm taking my integral, let's start with x. So I'm going to take my integral of dx dt, so that I find the x coordinate, or the x part of my position. And now for my bounds, what I'm going to do is start from the point that I know the value of. I know the value of the position at 2. It's 7. They told us that. Okay, and then I'm going to end at the time that I want to find out. Okay, so I'm starting at 2 because I know what's going on at 2. I'm ending at 1 because that's what I want to figure out. The reason behind that is when I do the first fundamental theorem of calculus, it's going to give me my position at 1 minus my position at 2. Okay, that's how integrals work. And I can solve for this. Okay, this is what I'm trying to figure out. This is my position at 1 in terms of x. So I'm going to add x of 2 to both sides. So I get x of 1 is equal to x of 2 plus the integral from 2 to 1 sine of t cubed dt. And now I know that this is 7. And all I need to do is figure out what this integral is. Well, all I got to do is go to my calculator, and I actually already typed it in, but you end up getting that this is 6.781. Okay, and as you can see, you probably guessed this is y, but we're going to go ahead and work out y. All right, so for the same thing, for my y value, I'm going to take the integral of this time cosine of t squared dt. Right, and same bounds because I know what's going on at 2, and I want to figure out what's going on at 1. And that gives me the y values at 1 and 2. Okay, now same thing, I want to solve for y of 1, okay, because that's what I'm trying to figure out. So that's going to be y of 2 plus the integral from 2 to 1 cosine of t squared dt. And now I know y of 2, they told me that it was 4. So that's 4 plus the integral 2 to 1 cosine of t squared dt, and I already did that in my calculator, so I go look at that, and I get 4.443. Right, so my final answer is going to be the vector 6.781 and 4.443, and that is my position. All right, that is it. See y'all later.